Hello, and welcome to the 52nd episode of the Crossing Thin Ice podcast series. Twice each month, we bring you a discussion of a variety of topics about risks and risk management for insurers. I'm Dave Ingram, and today, as always, I'm joined by Max Rudolph. Max will be diving into a topic that often gets overshadowed by discussions of rising temperatures and extreme weather. That topic is ocean acidification. The prospects of changing pH of the ocean has a number of very serious consequences that Max will lead us through in a few minutes. Acidification seems to many of us like an academic issue out of our high school chemistry class, but it is a very real issue that can have a massive impact on life in the sea, which ultimately affects the actual livability of the planet. A quick reminder, this podcast is not investment advice. We are here to provide thought-provoking discussions on topics of interest to risk managers. We hope that we do provoke your thoughts and welcome your feedback. So join us as we dive into this important topic, which we hope will lead you to think more about the ways that we can all help with reducing the carbon emissions that drive ocean acidification. Let's get started.
Climate change continues to upend our expectations. Scientists try not to scare us, but they have a limited historical data set to work from. They can't reach a 99th percentile result until 100 data points have been collected. While a picture of the distribution may be clear, the statistical result may be misleading with results more extreme than academia allows them to report. Many research papers have focused on changes to the atmosphere, with oceans being considered only via sea level rise. Found myself wondering about what lies below the surface of these great bodies of water and how the ecosystems interact with greenhouse gases. The science and the scenarios that result are fascinating but scary. Before humans came to dominate the Earth, natural cycles led to excesses and shortages, with recurring mass volcanic events releasing huge amounts of carbon, creating mass extinctions. 5 have been identified since the Earth was formed over 4 billion years ago. Even the asteroid strike that ended the dinosaurs' dominant run came at the end of one of these volcanic events 66 million years ago. They're not common. During the industrial age, humans have been releasing carbon dioxide, methane, and other greenhouse gases into the atmosphere, trapping heat and warming the planet. A warmer atmosphere holds more moisture, trapping even more heat. Wind creates an interaction between the atmosphere and bodies of water, with oceans absorbing about 30% of carbon dioxide and almost all of the other greenhouse gases. Carbon dioxide, added to the oceans, chemically reacts with the carbonate common in shellfish and coral skeletons, resulting in carbonic acid and hydrogen ions. The ocean is now more acidic by about 25% than it was in pre-industrialized periods. In addition to warming that makes hurricanes stronger, melts ice, and expands water volume. A more acidic ocean makes it harder for these corals and shelled creatures to form, and in fact, a shelled creature like a crab or lobster sees its shell dissolve in even slightly more acidic water. Some areas of the North Atlantic are becoming more acidic at 4 times the rate near the equator. This future will be very stressful for the ecosystem, especially due to the alarming rate at which this change is occurring. Another benefit the ocean provides to humans is movement of heat from the equator to the poles and cold back to the equator, using ocean currents sometimes called the global conveyor belt. This moderates temperatures in Iceland and northern Europe. Much as wind is driven by differences in atmospheric pressure between 2 points, ocean salinity and differences in density drive the currents. Saltier water is denser and sinks. Ice, frozen water absent salt, floats just above a layer of ocean that is subfreezing. The dense water sinks near the poles, creating a current to replace it, and rises as it warms near the equator, while also carrying nutrients from the depths to the surface. Cold water is notoriously low in nutrients, so this upwelling is very important for the ecosystem health. These interactions have been evolving over billions of years. There have been times when the currents have slowed and even stopped, sometimes abruptly. As ice melts and fresh water flows from land masses like Greenland, this changes the dynamic and slows the current. When ice no longer forms, it is unclear if the currents will stop or if a new equilibrium will form. Changes in rainfall patterns, creating new areas of drought and monsoon, would also be expected since the tropical zone where cyclones form is about 10 degrees north of the actual equator due to the existing system of currents. Some argue we are near various tipping points that could cause a cascade of accelerated warming. Melting ice sheets in the Himalayas, Antarctica, and Greenland, Amazon dieback, and permafrost melt all create feedback loops that seem likely to accelerate warming. To this, we can add a threat multiplier, the current in the North Atlantic no longer carrying warmth to Northern Europe and the United Kingdom. A mass migration event due to what were thought to be local famines and extreme weather across the Northern Hemisphere followed the year without a summer. This came after the eruption of Mount Tambora in 1815 that cooled the Earth by less than 1 degree Celsius. In our 2022 podcast 16, I described the movement from Europe to the U.S. Northeast and from the U.S. Northeast to what was then considered the U.S. West, areas south of the Great Lakes. 6 new states were recognized during that period, from Alabama to Missouri. If the Atlantic Meridional Overturning Circulation, or AMOC, were to cease, temperatures in England would cool by at least 5 degrees Celsius. Podcast number 22 described ways that risk could interact, causing havoc to social and economic order. It seems clear that continuing on the current path is bad news, somewhere between challenging bad and ecosystem collapse bad. The best case under the current path was sea levels 3 feet higher than today by 2300 and food security dependent on technology is a result that everyone should want to avoid. As interesting as the science is, the ramifications of acidic oceans and oceans without currents should encourage everyone to transition their use of fossil fuels to renewable energy sources.
And I heard you call that the AMOC.
Yeah, the Atlantic Meridional Overturning Circulation.
I know how to find the temperature now. How do I find the temperature in the past? And sometimes we're talking about far into the past.
Scientists have determined that ice cores taken where snow has accumulated can be mapped to historical time periods. So that's in places like Greenland and Antarctic where they take these ice cores. The atmosphere from that time is frozen in the core, so the melted gases can be analyzed. To go back to years prior to the most recent time that Earth was free of ice, they have to look at ocean deposits that have become rock, been pushed up and are now mountains when they're doing their analysis. It's harder, but still possible. I'm just amazed at what these climate and geology specialists, have figured out during their studies. But they continue to expand their knowledge and they're learning all the time. I mean, it wasn't that long ago that plate tectonics was developed, certainly in my lifetime.
You mentioned there, Max, going back to the most recent time Earth was free of ice, as if we should all remember that. How long ago are you
We're not
talking
even
about?
old enough for that.
Is that millions of years ago
Yes.
or
Yeah, before the at least the last ice age, and probably earlier than that.
sure? Listening to a lot of these stories about this, it seems like there's often a miss. The actual results are worse than what the client scientists expect. What causes that?
I think most of it is due to statistical norms. So many of the measurements have not been collected for very long. If you have 50 data points, the most extreme result is 1 out of 50, and that's the 98th percentile. You can't get to 99% with only 50 measurements. In addition, the statistical terms used don't always align with their common use. They define likely as 66th percentile, very likely as 90th percentile, and virtually certain at 99th percentile. So about as likely as not covers everything from the 33rd to the 66th percentile. So in a normal distribution, the result must be, about one standard deviation above the mean to be considered likely. Scientists also worry about overstating their case and sounding alarmist, so they tend to soften their comments. Most of us knowingly do this in our own work, knowing that the listener will compensate, but this tends to be an adversarial relationship when this research is being interpreted, and so a quote can be used without that interpretation. So it's kind of buyer beware. Make sure you're listening and that you understand that. Always ask for the data to be presented as a graph. Especially with climate research, pictures just tell a great story that help you really understand the results that are being talked about. So Dave, we're seeing heat waves and drought impact mortality and morbidity, especially for the lowest socioeconomic classes. What are some other long-term implications of rising morbidity and mortality risks due to climate change?
Well, Max, from my experience, I would say it's going to require a big shift in thinking in the folks that are managing life insurance companies. During the time I worked in life insurance, we always thought of the almost guaranteed annual mortality improvement as something that made it a little easier for us to manage our expenses. That if expenses had a constant drift up because inflation was always there, at least we had something going the other way of mortality improving that. If mortality improvements aren't there, it means the pressure is going to be on insurance rates because they're going to look like they're going up just like everything else. Insurance, we won't be able to sell insurance as a bargain that hasn't gone up as much as inflation would has a lot of other things going up. So we're going to have to figure out how to sell our product a little bit differently because the economics of it will work out differently. So, Max, with oceans warming, are we finding that fish and animals are moving to new areas?
Yeah, thanks, Dave. Fish and other types of animals are definitely migrating to places that resemble where they ended up, 200 years ago after millions of years of evolution, so pre-industrial revolution. As water warms, fish move toward the poles, leaving areas with lower oxygen and warmer temperatures behind. As the atmosphere warms, animals move to the poles and to higher elevations. Migration patterns change. Mosquitoes will carry dengue fever to areas that used to freeze during the winter. Tarpon, fish commonly caught off Florida, are now seen off Cape Cod. We're in a period of accelerating extinctions. Some say this is the sixth mass extinction, which would require 75% of species to disappear. But there's still time left to avoid a biodiversity catastrophe if we take this growing problem seriously.
Well, this all seems to be happening very, very quickly. What are the implications of that?
Yeah, Darwin's theory of evolution requires time. The rapid changes driven by our use of greenhouse gases makes it very hard for animals that live long lifespans to adjust and survive. Insects, think about this, they reproduce many times in a year, so they stand a fighting chance. And that's probably why cockroaches are one of the animals that survive through anything, is because they reproduce so often.
So, Max, you're always challenging my reading abilities here. So, if the that AMOC, which you tell me is the Atlantic meridional overturning circulation, if that materially slows down, what happens? What can we expect?
Yeah, the ocean's conveyor belt carries heat in the Atlantic Ocean north from the equator and impacts the location of hurricanes, cyclones, and typhoons. It actually moves that area where those form a little bit north of the equator. A weakening AMOC, or like I would normally call it the Gulf Stream, means the hottest areas get hotter, and areas like Britain and Norway would get colder. Um, you know, and that would be as the Gulf Stream weakens. It's not just the switch that turns on and off. Wet and dry patterns will change on most of the continents. Some will get wetter, some will get drier, some will have more storms, some will have fewer. Another expectation is that the temperature differential between Scandinavia and Middle Europe, so northern Germany, that area, will be large, and will create that differential will create winds and strong storms south of the Baltic Sea, which would make it a difficult place to live.
Well, I'm trying to project that out in my head, and I'm seeing a Mad Max movie. Is that where we're heading?
Well, probably not in my lifetime, and not solely due to climate change. I mean, there's nuclear war and other things that we could impact that could lead us to such a scenario. But unless we develop tools at scale to take carbon out of the atmosphere and the oceans, areas already impacted by heat will become too warm to support large populations, and weather extremes will make some areas inhospitable and expensive. South Florida is a good example where concerns are suddenly rising with the recent hurricanes. The cost of insurance is a leading indicator, but sea level rise and stronger storms are quickly changing the dynamics in the area. The loss of ice will result in polar bears becoming land-only creatures foraging for food. But think about other animals in other places that are specialized and will have to quickly adapt, like those who live in the Everglades or the deer in the Florida Keys. Some have said that a 3-degree increase from pre-industrial temperatures will result in 50% of all species alive at that time becoming extinct. That would create its own feedback loop with alignment gone between pollinators and plants, migrating birds and food. I mean, it's a big deal. We need to take the time to deal with
Well, thanks, Max. It's always great to finish with your uplifting comments.
it.
Ocean acidification is one more piece of the climate change puzzle, along with rising temperatures, rising sea levels, and increases in extreme weather events. Individuals, organizations, businesses, and governments all have a role to reduce carbon emissions and moving forward deliberately with steps to adapt to the climate change that has already been triggered. We need to strengthen our commitment to climate science so that we have the analysis available to help us to decide what and where our efforts will have the most significant impact. The insurance industry has an important role to play to help with nudging behaviors in the right directions, sometimes subtly and other times not so subtly through pricing and underwriting actions. Max, thanks for bringing us another challenging emerging risk discussion. And thanks to you, our audience, for listening. If you liked today's episode, please like, subscribe, and share with your friends. And join us soon for episode 53.